Now, question number 5. Calculate the number of atoms of oxygen in 0.2 mole of this. Here, 0.2 mole of Na2CO3.10H2O is given. And we have to calculate number of atoms of oxygen. We can say 0.2 mole of Na2CO3.10H2O. This is equal to 0.2 into Na particles of Na2CO3.10H2O, because 1 mole is equal to Na particles. I describe you in the first lecture. Now look here, this Na2CO3.10H2O. Look this 3. Look this 3, and look this 10. So you can say one particle of Na2CO3.10H2O that contains 13 atoms of oxygen. So we calculated here 0.2 Na particles. They will contain 13 into 0.2 Na atoms of oxygen. It is 2.6 Na atoms of oxygen. It is 2.6 into 6.02 into 10 to the power 23 atoms of oxygen. So this is the right answer. Make the calculations. Now it is very easy. After this, question number 6 is given. Although I don't give you any idea of the molarity, but here in this question molarity is given, so you can say molarity is nothing but, this is question number 6, this was question number 5. Molarity is nothing but number of moles upon volume in terms of liter. Here this is molarity, it is given 1. Number of moles upon its volume, it is given 100 ml. 100 ml means 1 liter, because we have to take in terms of liters. So number of moles of what? CuSO4, copper sulfate, this is equal to 0.1. Now a number of moles of CuSO4, we have to calculate, find the number of atoms of find the number of sulfate ions. Sulfate ions, CuSO4, it is Cu plus 2 plus SO4 minus 2. If it is 1 mole, then look here, it is also 1 mole. So you can say 1 mole will give 1 mole of this. It means 0.1 mole will give 0.1 mole of this. So number of moles of sulfate, this is equal to again 0.1. If this 1 mole is producing 1 mole of this one, it means 0.1 mole will produce 0.1 mole of this. Now we have not to calculate the moles of sulfate. Here we have to calculate the ions of sulfate. How many ions are there? So we can say 1 mole is equal to Na particles. So number of sulfate ions, this is equal to 0.1 into Na, and 0.1 Na value is 6.02 into 10 to the power 23. So this is the right answer. Now friends, we should solve some more problems too. Here after this we have to solve question number 6. Question number not 7, because we solved to these two. Question number 7. Find the total number of nucleons. So nucleons, it is particles present in nucleus. Particles present in nucleus. Protons and neutrons are present in nucleus. So nucleons means number of protons plus number of neutrons. So first thing what you have to calculate, you have to calculate the nucleons, means you have to calculate the number of sum of protons and neutrons. Now what given here, 12 gram of carbon 12 gram of carbon 12, it is 1 mole of carbon 12, because you know atomic mass, if it is X, so here one information to that we can say it is X gram per mole, and another X U per atom. So here 12 gram is given, and 12 is atomic mass of carbon. Now so we can say 12 gram of carbon is 1 mole of carbon 12, and 1 mole of carbon 12, it is 6.02 into 10 to the power 23 atoms of carbon 12, because you know very well that 1 mole is equal to 6.02 into 10 to the power 23. Now dear friends, we have to calculate the nucleons. We know in the carbon 12, since one atom that contains 12 nucleons, 12 nucleons, which is 6 protons plus 6 neutrons. So since one atom contains 12 nucleons, so here we can say 6.02 into 10 to the power 23. Here this value of atoms that contains 12 into 6.02 into 10 to the power 23 nucleons. This is our right answer. So there are very little things to that we should know. Now question number 8. What question number 8 is telling? Find total number of neutrons. Here we have to find total number of neutrons and the mass of neutrons in 7 milligram of carbon 14. Here 7 milligram of carbon 14 is given. So we can say 7 into 10 to the power minus 3 gram of carbon 14 is given. Here atomic mass is given 14. So one meaning to that we can find out, it is 14 U per atom. Another meaning to that we can find out 14 gram per mole. And now we should select here this one. It means 14 into 1.6 into 10 to the power minus 24 gram is equal to 1 atom. From where I am writing this? Because we know that 1 U is equal to 1.6 into 10 to the power minus 24 gram. And also the same time I am telling you one more thing, that 1 upon 6.02 into 10 to the power 23 is equal to 1.6 into 10 to the power minus 24. Remember these calculations. So we can say this particular value 7 into 10 to the power minus 3 gram is equal to 7 into 10 to the power minus 3 divided by 14 into 1.6 into 10 to the power minus 24 atoms. So here you can divide, it is 2, but don't try to do anything else because you have to apply this concept here. So you can say 1 upon 2 into 6.02 into 10 to the power 23, and here already 10 to the power minus 3 is already present. It is here atoms. So what is the calculation of this? It is 0.5 and into 6.02 into 10 to the power 20 atoms. Now what we have to calculate? We have to calculate total number of neutrons present in this. Dear friends, it is 6C14. So in this particular one atom, a number of neutrons, here it is 14 minus 6, it is 8. Since one atom contains 8 neutrons, so we can say here this 3.01, I am multiplying this into 10 to the power 20 atoms, that will contain 8 into 3 into 10 to the power 20. It is 10, I am taking approx values, it is 2.4 into 10 to the power 21. This is our right answer. So the find out total number of neutrons. Total number of neutrons is this, and what the mass of neutrons present in this, we have also calculated the mass of neutrons present in this. One thing you should also remember, I am writing these values, approx values. Why? Because in the calculations we have to take the approximations. Mass of one proton, it is approximately equal to mass of one neutron, and it is approximately equal to 1.6 into 10 to the power minus 24 gram. And its calculation I told you already, 6.02 into 10 to the power 23 gram. I told you already. So since number of neutrons they are this value, and the mass of one neutron it's given to you, so it is very easy to calculate the number of neutrons present here. And the next question, here it is telling don't go on the hints etc given here, don't use the hints etc. Now the next question, that is ninth, how many moles are there in 1 cubic meter of any gas at NTP? So 1 cubic meter is equal to 1000 liter at NTP. It is given to us. We know that 22.4 liter at NTP is equal to 1 mole. So 1 liter is equal to 1 upon 22.4 mole. So we can say this particular value 1000 liter, this is equal to 1000 divided by 22.4 moles. So this is very easy, there is no any problem in this. You should note here again 1 cubic meter or 1 meter cube, this is equal to 1000 liter, and 1 cubic decimeter, this is equal to 1 liter, and 1 cubic centimeter, this is equal to 1 milliliter. This also sometime abbreviated as cc, cubic centimeter. Now here again a question of molality is given, although I don't teach you molality, but no problem, these things are very easy, and these must be very easy for a competitive student. 3 gram salt of molecular mass 30, 3 gram is given, and molar mass or molecular mass, here it is 30 in 250 gram of water. Mass of water, it is 250 gram. So note here molality, it is equal to mass of solute in gram upon molar mass of solute into mass of solvent. If we write here in K in gram, then here we have to multiply by 1000. So apply the same formula. Mass 3 gram of solute, it is solute and it is also solute. So 3 gram of solute whose molecular mass is 30, and if the solvent, here it is solvent, here 250 and here is 1000. So these things are very easy. Here you calculated, you got the correct value.